Yeah, hello everyone. Today we'll continue with sliding window pattern. And in the previous session, I think I forgot to explain about the time complexities. We'll cover that time complexity details in this session. Okay, let's go through this one. The problem statement is this: given a binary array numbers, which can be only one or zero, return a maximum number of consecutive ones in this array. So in this case, as you can see, is two ones only, that is 2, and there is a 0, so we can't count this. And the next one is these 3 ones. So here in this case it's 3, right? um, so let's first try to solve this uh, using brute force. In brute force approach, what you can do is you can just run two loops. So I'll just briefly explain brute force because it will give us some idea how to optimize, right? So there will be two for loops, right? First for loop, you'll iterate. Okay, let's take this example, right? And we have this 1 1 0 0 0 1 1 1, right? So uh, the outer loop will count one index, and will keep on checking if there are any consecutive ones in the second for loop, right? For loop. So first we'll start at 1 and then 1, so it's a 2, and then I will hit at 0, so we'll exit from the second loop, and again we'll start from second index. So you can just see it's obvious, right? It's a of n squared complexity. So I'm not going to delve into much details into that. So let's see how we can optimize that further, right? So as you can see in this, there is this consecutive elements. We are looking for consecutive elements, right? So that is one hint for optimization using sliding window pattern. As you can see, maximum number of consecutive ones. This is the a keyword here. So consecutive ones, we're looking for a contiguous subarray here. So how we can do that? So it's simple. So as we discussed in our previous session, right? So first, we'll have two pointers. One is for like starting and end of the queue, and we keep on expanding the queue. So in this case, what is the condition, right? If it is 1, we'll expand the queue, right? And if we hit 0, it's time to shrink the queue. In this case, you can just completely let's go through this example, right? So first we'll start at 1, and both left and right are at 0. So we can just expand the queue, and the length will be, in this case, length will be 1. So second one comes, so we'll expand the queue, length will be 2. Now now there is 0. So what we need to do in this case, we can't expand it further. We need to shrink it now. So what we can do from the start, you can just come and keep on going, or just with one point, right? We can just initialize the queue again back to the next fresh queue. We can start a fresh queue in this case, because anyway, you can keep on decrementing all the ones from the queue and it will hit the 0. So there is no point to like go through the while loop. We can just directly start a fresh queue that is from the next this one. So now both left and right pointers are set to index 0, 1, 2. No, 3, right? And we'll again start a fresh queue, and length is equal to 1 in this case, and again 1 comma 1, length equal to 2, expand the queue. So this is the idea roughly. So we are using sliding window pattern here, right? This will work for you in this case. You can try that out. In this case, first one, and then we'll reset the queue, and again these two will be the output, right? And so on. So the maximum length is 2. So this is the idea roughly, and let's code this now. So first write the boundary conditions. If it's empty, it's just return 0, right? Now initialize the pointer, right pointer, max length equal to 0, right? Mm. All right, so I think you are aware of this template, right? You can just, I just want to share if template is there. You can just see this template here, right? So this is what we're going to do. We'll process the right pointer and we'll keep on expanding based on the condition. And if it is not, the condition is not satisfied, we'll check how to reduce the queue. So this is roughly the idea. And let's go to the code now. So and right pointer less than. Now we will process the right pointer. Nums at right pointer is equal to 1. So this case, right? All these cases. We're just incrementing the pointer and keep track of the maximum and so forth. And continue so that it will like come out of this loop and it will go to the next pointer. So if it's not 1 in this case, right? So what we're doing here, we are incrementing the right pointer so that it will start afresh to the next pointer. And the important thing is we are setting the left pointer to the right pointer so that we are starting a new queue here. So yeah, this is expand queue case and this is string queue case. I think that's about it. Excellent. Try to run this. Yeah, that's good. Yeah, that's about it. See the use of having a standard template, like we can code really faster, and yeah, you can just follow your own code template, right? And yeah, so now let's discuss about the time complexity here. So in brute force approach, it was obvious, right? It was O of n square, right? So in this case, what is the time complexity here? So take any element in the array, right? So what we are doing, we are either adding to the queue, right? Just adding to the queue, and we keep on incrementing it. So if you see there is really only just one loop, right? And if it is not satisfying the condition, you're just resetting the queue. So we're actually processing like only one time any element in the array. So yeah, and we are not using an extra space, just 2 pointers. So yeah, this is the space complexity. Actually, that's about it. And we'll solve one more variation of this, which is maximum consecutive ones 3. It's a follow-up of this, and it's very interesting actually. Same settings, and this time there is one extra condition here, which is a k, and you can flip at most k zeros. So we can make zeros to 1, and you can do that at most k times, right? And that is the condition here, right? So let's think, and let's first try with the brute force how we can do this. So our for loops, right? So like first for loop, just this is just I won't go into much detail. So first for loop will iterate over one, right? So let's say one is there. Index equal to 0 is our outer loop. It is the first for loop, and we'll start from index equal to 1 and so on, right? So we scan through this entire array in the second, I mean second loop, right? Okay. So index 1, 2, so this is 1, this is 2. Now there is a 0 now. So since k equal to 2 is there, we can take that also and increment k, decrement k. We can do one more time, right? And that's about it. We can't go till this point. So at most we can reach 1, 2, 3, 4 to index 4. This iteration is done. Length equal to, in this case, 5. Maximum length is 5, right? So now again index 0 is done. Will come out of this outer loop, right? Now again the loop will start. So index equal to 1. Again we'll scan from index 2 to wherever you can go. So these are roughly idea, 2 for loops, and this is brute force. And time complexity will be n square. So now let's try to utilize what we did in the previous round, right? We used the sliding window pattern, and how we can apply this. So we can use the same approach here. Uh, Only thing is we'll see how to. So the expanding queue is same. If you just encounter one, just expand it. And if it's not, if it's 0, we need to write one more condition, whether it's within our allowed limit, right? And if it is so, we will expand the queue again. And if we run out of the k limits, we need to again shrink the queue. That's the idea, right? Let's see what I meant. The first one is there. Keep on incrementing. No problem. 1, 1 will increment. 1, 1, 1 will increment again. Now 0. We came across a 0. So we'll increment. So we'll flip that actually. That means it's a 1. So k will be 1 now. Again 1, 1, 1. One more 0. K equal to 0 now. We decremented it. And maximum length so far is 5, right? And again a 0 came, so we can't increment any further, right? Time to shrink the queue. At index, which is 1, 2, 3, 4, 5, 6, index 5. So we keep on decrementing once from the left side, right? And also you can decrement 1, 0 also, so that we can expand from right side. So this one will be gone, this one will be gone, and this one will be gone, and this 0 also will remove, right? And we can add the element at index 5. So this is what our queue looks like now, right? And next element is 0, 0, 0, 1, 0, 0, 1, 1. Okay, 0, 0, 1, 1, 1, 1, 1, 1. One more one is there. This is the maximum possible length. Yeah, this is maximum than 5, so we'll keep this as maximum. Right now, one more 0 comes. So we can, so in this case, what we can do is we can try to decrement from the left. So actually, it's what we can do. So let's say I'm just considering one more case. So we can just remove zeros. 0 0 will remove. Only 1 0 we can just remove 1 0, right? Yeah. If you just remove 1 0, it's like again and 6. The same output, right? Yeah. Yeah, that's the idea actually. So when to expand the queue and when to shrink the queue. Now let's try this in the code. So just a corner cases, important to have this. And now let's see. Right pointer is less than length. Process the right pointer first. It's equal to 1. Just expand the queue, nothing to do, yeah. And capture the max length. Continue. Now the interesting case is when it will come outside of, so when it's 0, what you will do. So first thing is when it's 0, this is the case, right? We decremented the key, right? And if it is within the limits, what we did is we expanded the queue. The same thing. Just to try to have this kind of code where we are dealing with different conditions differently, so that it's easier to debug. It's the same thing, right? Right pointer, increment right pointer, and max length. So same thing what we did for this case, right? If it is outside, I mean, we kind of spent all our case, and this is the case now. What we need to do? Time to shrink the window. So this is what we did. We kept on. We kept on uh, decrementing from the left side, right? It's condition, and what we are checking is nums of left pointer. If it's 1, keep on decrementing that. Right, we kept on decrementing it. Right, and so we didn't take the last 0 also, right? We kind of ignored that, right? So now, right pointer, we need to increment left pointer also. Just run through that example, it will be clear why I'm incrementing left pointer also. Because here in this case, right, we're shrinking it, we shrinked it, and we're starting a new queue. So this 0 also is kind of deleted from the queue. So that's why I'm incrementing left pointer also. And here also the same thing. We're just deleting 1 0. So at this point, what essentially we're doing is uh, we are kind of having k minus 1 zeros, right? And we're trying to have the like we're keeping a buffer of last 0. So if you just go through this example, it will be clear what this meant. Why I'm incrementing left pointer, right? Yes, that's about it. Just checking. Okay, left pointer, right pointer. I think just it should go through. Yeah, looks good. Invariant at this point, what I'm feeling is like this k minus 1 zeros are flipped, and we are seeing like the last 0. We are using that. Yeah. Mm, Good. Perfect. Yeah. So here also, right? If you see, take an element, uh, we are touching it as at most 2 times. Uh, while expanding Q or shrinking Q. That's about it. And we are just at most 2 times. So O of 2 times into n, which is nothing but O of n. And space also, we are not using any space. Yeah, that's about it. Thanks for watching. We'll come with like I'll try to cover as many problems as possible for this pattern. Yeah, thanks.